Hi and welcome to this second video on SOHCAHTOA. Today we're looking at the sine function, one of the three trig functions that we looked at in our previous video. So a quick recap of video 1. If you haven't watched this, I encourage you to do so before watching video 2. We investigated right angle triangles for a start, and we were discussing this in the context that all of these three trig rules only work for a basic right angle triangle. We then looked at the labeling of the various parts of our right angle triangle. So we have the hypotenuse, the opposite, the adjacent side lengths, as well as the angle which uses the symbol theta. We looked at the division or ratios that we use to calculate the three functions of sine theta, cos theta, and tan theta. And they're based on the ratio of sine of the angle theta is equal to the opposite side length divided by the hypotenuse. And those three letters give us the acronym SO, S-O-H. Cosine of the angle theta is equal to the ratio of adjacent side length over the hypotenuse side length. And those three letters, C, A, and H, give us the acronym of CAR. And tangent of the angle theta is equal to the ratio of opposite side length over adjacent side length. And those three letters, T, O, and H, give us the acronym TOA. So together we have SOHCAHTOA as a quick way to memorize the functions of sine, cos, and tan. So on with today's lesson. All three trig functions, sine, cos, and tan, require an angle, theta, and two side lengths. So in the case of sine theta, we have the side lengths opposite and hypotenuse. In the case of cos theta, we have the side lengths adjacent and hypotenuse. And in the case of tan theta, we have the side lengths of opposite and adjacent. So let's look at the sine function. Recall that sine is equal to opposite over hypotenuse. So we're looking at the sine of this angle theta, the opposite side length, and the hypotenuse side length as shown in green and red. So here's our starting equation. Let's see if we can't derive some new equations from this starting point. If I were to multiply both sides by the hypotenuse, so on the left hand side of my equals, I multiplied the sine theta by hypotenuse, and on the right hand side, the opposite over hypotenuse fraction, I multiply by the hypotenuse, we can see that there's a simple cancellation here, which gives us a new equation. Hypotenuse times the sine of the angle theta is equal to the opposite. Or, if we rearranged, the opposite side length, here represented by green, is equal to the hypotenuse side length in red, multiplied by the sine of the angle theta. All right, so that mathematically is a second derived or generated equation from the sine relationship. Let's continue on. We go back to that starting point where we had hypotenuse times sine of theta equals opposite side length, which is really just this in reverse. Let's see what else we could do from here. If we divided both sides by the function of sine theta, so on the left hand side we have hypotenuse times sine theta, now divided by sine theta, is equal to the opposite side length also divided by sine theta. So we've divided the left and right hand sides by the function sine theta. We can see here there's a simple cancellation on the left hand side of our equation of the sine theta on the top of the fraction and sine theta on the bottom of the fraction. They divide through and cancel out. And we're left with the hypotenuse side length is equal to the opposite side length divided by the sine of the angle theta. So that's our second derived equation from our original sine function. There's one more to consider. Let's go back to our starting point. Now we've rearranged this to find the opposite in an equation, the hypotenuse in an equation. What happens, however, we want to find the angle theta? At the moment, it's in the middle of a function called sine. Now before, we got rid of multiplication by dividing, and we can get rid of dividing by multiplying. And previously we've looked at how we can get rid of squaring something by taking the square root. Well, the reverse mathematical function of sine is what we call the inverse of sine, and you can find this on your calculator. So if I take the inverse sine of both the left and right hand sides of this previous equation, I have inverse sine of the sine of theta. Now the inverse sine and sine cancel out, and I'm now left with the angle theta is equal to the inverse sine of the opposite side length divided by the hypotenuse side length. That's my third and final derived equation. Let's now look at our summary. So the opposite equals hypotenuse times sine of theta is used to find the unknown side length. The hypotenuse is equal to opposite over sine theta is used to find the unknown hypotenuse side length. And finally, theta equals inverse sine of opposite over hypotenuse is used to find an unknown angle. Remember, sine is to do with the opposite side length, the hypotenuse, and the angle theta. Now, with these three equations, we can solve any unknown, whether it be opposite, hypotenuse, or the angle for a sine function. Let's have a look at three examples. First of all, opposite equals hypotenuse times sine of theta is used to find the unknown opposite side length. So here we have an example of a right angle triangle with a hypotenuse of 8 meters, an angle of 30 degrees, and an unknown side length of x. So this would be the correct equation to use. Another variation, we could be asked to find the unknown hypotenuse x given the opposite side length of 10 meters and the angle of 45 degrees. In which case we'd use hypotenuse is equal to opposite side length over the sine of the angle of theta. And finally, we look at the third example where we've been given both the opposite and the hypotenuse side length and we're asked to find the angle, in this case x. The general equation is angle theta is equal to the inverse of sine of the fraction opposite side length over hypotenuse side length. Now let's solve these three examples. Number one, calculate the unknown opposite side length for the triangle shown below. We know the opposite side length is the unknown. The hypotenuse is a known 8 meters and the angle we have theta is 30 degrees. So at this point we've got 1, 2, 3 equations to use. We're after the opposite, so let's choose the equation with the opposite on the left hand side. So the chosen equation is opposite equals hypotenuse times the sine of theta. Let's choose that and substitute our values in. So opposite is our unknown, it stays as just opposite. Hypotenuse is a value of 8 and the theta has a value of 30 degrees. Let's now place this in our calculator to find our solution. Okay, so we want 8 times the sine of 30. That gives us a value of 4. Okay, so the opposite is equal to 4. The unknown opposite side length for the above triangle is 4 meters. Example number 2. Calculate the unknown hypotenuse side length for the triangle shown below. So again, our opposite side is 10. Our hypotenuse is unknown, it's the x. Our angle is 45 degrees. Which of these three equations is appropriate? Well, our hypotenuse is the unknown, so let's choose the equation that shows the hypotenuse by itself on the left-hand side. Sub in our values, hypotenuse is the unknown, opposite is 10, and angle is 45. Let's put this in our calculator to find a solution. Okay, so we want a fraction with a 10 on the top, divided by the sine of 45. And that gives us an answer of 10 root 2, which is what we call a surd, an exact value. I can hit the button here, which converts it to a decimal of 14.14. So the hypotenuse is 14.14 meters. So to answer this question, the unknown hypotenuse side length for the above triangle is 14.14 meters. Our final example, example number 3, calculate the unknown angle for the triangle shown below. The opposite side length is 5. The hypotenuse is 5.77, and we're after this unknown angle x, so theta equals question mark. So which of these three equations do we use? Of course, we want the one that's got theta by itself on the left-hand side. Theta is equal to inverse sine of the opposite over hypotenuse side lengths, and that's our chosen equation. Let's now substitute our values in. The opposite side length was 5 meters, and the hypotenuse side length was 5.77 meters. Let's calculate that with our calculator. Okay, we want the inverse sine, second function sine. You can see there's an inverse sine function there. And we want to put a fraction in this with 5 on the top, the numerator, and 5.77 on the denominator. That gives us a value of nearly 60.06 degrees. So we found the unknown angle to be 60.1 degrees. So to answer this question properly, the unknown angle for the above triangle is 60.1 degrees. So I hope this video has helped consolidate your understanding of sine and how we can use the sine function to calculate both side lengths that are unknown and an angle that's unknown. Now, if you've enjoyed this video, please like, share, and comment, and don't forget to subscribe. And as always, thanks for watching.